And so the physical chemistry is really how the intangible chemical world connects to the tangible world. So let's dive into those things. The tangible or physical world involves these kinds of measurements. And this course is spectroscopy and quantum mechanics. So spectroscopy is the way we connect to that intangible world using the intensity of light. So you've already used some of this in your instrumental classes and so on. Whenever you take a light measurement, absorption, transmission, and so on, you're using that tangible effect, your eyesight, or maybe we make a machine that sees better than we do, like a spectrometer, but it's still looking at the variations in intensity of light. So that's one of the best ways to use a tangible signal to measure the intangible. Those signals are typically turned into electrical voltage or current. And so we see that here's a photomultiplier tube, here's a photodiode. These are the two tools that we'll use this semester to measure vibrational motions in benzene or scattering of light off of molecules and so on. We also can measure or talk about mass, pressure, volume, temperature, all of those things. Heat, we measure heat in and into and out of a system by measuring temperature. And then work we use by changes in height or against gravity and so on. Back to mechanical physics. If you can lift a weight, you can calculate how much work you're doing. Now the work and heat, those are going to be in the spring semester. So hopefully you'll stay with me, even if it's not required, say for your forensic chemistry degree. Thermodynamics course is a really fun course. A lot of people really like PChem 2 a lot better. So sort of prepare your mind if you wanted to pick up an elective. It's a powerful elective. It's not a writing component, so there's much less writing. And it's more of a survey of chemistry. It's like diving deeper into Chem 2 and looking under the hood of all of the engines and things that make our world move. Now, the intangible world, the chemistry world, involves this idea like from Ant-Man and Wasp, the quantum realm, right? So they shrunk themselves down and now they're in the world of wave functions and so on. This is what we want to know about because chemistry takes place at the sub-nanometer scale. And so how do we use pressure, temperature, and volume to measure something that's taking place in that such a small scale? And so this is what I mean by the intangible world. And it contains all of these mysterious things. Now the distance scales and energy scales that we use in PChem are probably larger than any other chemistry class. Now there's not a lot of math in physical chemistry, but math is a prerequisite. And we'll start out with some calculus in the lab and so on. We'll do a lot of our math in Excel because it's so much easier to use. Okay? But look at some of the energy and distance scales. So in PChem 2, by the end of the year, we're talking about world energy usage, and that's in exajoules. Exa is 10 to the 18. So you guys are familiar with, mega and giga, and maybe now with like storage of bytes, hard drives, and so on, terabits of information or terabytes. But there's also peta and then exa. So exa is 10 to the 18. And so instead of writing all of these zeros, 18 zeros behind 425, we could substitute that by the capital E. The only downside of that is it's a capital E, which most of the time we talk about energy. So context matters for all of your units. It's a prefix. EG is exajoules. We also deal in microns, the distance scales. We get into the quantum realm, whatever that means. It emerges at the nanometer scale. The one area of science that I've seen in my many years in science that really isn't overhyped is this idea of nanoscience. Because when does a material change from the atomic scale and its behavior as an atom, single atom in space, to the bulk scale where it behaves like a bulk material? It does that switch over in the nano range. So when it gets to 100 to 1,000 nanometers, the properties are weird. They're a mixture of atomic properties and bulk properties. And so it's essentially a way to expand the periodic table. We know the chemical properties of all the elements on the periodic table. And those are the atomic properties, and we know their properties as bulk materials, melting points, and so on. The nanoscale, they behave really strangely. And so making nanoclusters, that's an area of science that has not been overhyped. you see the craziest results out there by looking at these nanomaterials. So that's fun. So when we get to the nanometer scale, strange things start to happen. And then down sub-nanometer, like the bond length of a hydrogen atom is an angstrom. So get familiar with this unit. We use it a lot. All of our bond lengths will be listed in angstroms. That's 10 to the minus 10 meters. Okay, that's not quite one of the powers of 3, like 10 to the minus 9. That's a nanometer. The angstrom is its own sort of unit, an A with a little circle on top, and that's 10 to the minus 10 meters. And then we get down in terms of energy. The energy of a single hydrogen bond is a zeptojoule, lowercase z, and that's 10 to the minus 21. So instead of writing out all of these zeros, we can just simply write that out as a lowercase z, 32 zeptojoules. So pretty exciting range of materials, a range of numbers in terms of energy or in terms of distance scales that we cover in physical chemistry. So what I'm trying to do with all of this is trying to get you interested in it. Because if you're not interested in it, if you don't desire the material itself, it won't stick in your head. And so this is a quote that somebody just put on the end of their email one time. It was a person on campus. And, I was reading through the email, and then I got to the end, and I thought, wow, that is a beautiful quote for PChem. Why do I think that is a beautiful quote for PChem? PChem doesn't make sense. It's right. Sometimes you're looking at it and you're like, I don't get this. I like organic, right? I hate molecules and reactions and things like that. Yeah. Or stoichiometry. Maybe you like to calculate how many moles you needed to burn this much methane and so on. We get into some of those things, but PChem is a little stranger. It doesn't feel like chemistry sometimes. Okay, so you're chemistry majors, so you like chemistry. So you got to find something in PChem that you like, or it won't stick. So this also asks the question, why are you here? Like, what is your goal? What do you desire for being here? Let's just popcorn. Why are you in this course at this time in your life when you could be doing something else? Skip the first person to go to the second. Yes. Exactly. So you've got a clear path. Get your degree and get a job. And raise your hand if that's your reason. Exactly. So well done. Spoke for the class. Okay. That won't help you remember the material. It's a laudable goal. You have a job that you're aiming for. You have a degree that is on the path for that. And this course is on the path for your degree. But that is not something that you know. That's sort of a procedure that you're following. But the tests, the exams, the homework, the lab reports are about what you know. And that material has to stay in your brain somehow. So if you don't desire the material, it won't stick. So I'll do my best to try to put out interesting facts and so on about what we're studying, but you've got to bring your own desires to the course. So you've got to find something neat about it. I'm surprised that I'm pretty bad at memorization, but yet I'm pretty surprised at how I can come out of a movie that I've watched for 2.5, sometimes 3 hours and quote whole paragraphs of text from the dialogue. Why is that? Because I really enjoyed it. I really desired that interaction that I saw on the screen, and it stuck in my head. And with just one pass, and boom, it was on in my memory. And so that's the kind of thing, you got to make your brain sticky. You got to think about the material and find something that you like about it. Maybe you like spectroscopy in terms of all the colors we see in our world. We're going to explain exactly how that happens and the pigments of your eye and so on in this course. If you like color, that's spectroscopy. Okay. So you bring that part to the game. Okay. And trying to figure out how you can desire the material so that it sticks in your head. We all have a knowledge tree, I think, of a tree of knowledge in our brain. Maybe there's some physiological truth to that, but I think of it as a tree. And you've got limbs of knowledge that are different branches, like an organic branch. Okay, maybe you have a history branch and so on. And then as you learn more material, you can hang it on that branch. Okay. Now we do some things with organic molecules in here, but if you're with the type of student who, when you walked out of organic, you reached up and took that organic branch and sawed it off and got your grade and threw the branch in the trash. Then when we start talking about organic molecules, you're at a loss. You know, you've forgotten your nomenclature. I say 1,2-dichloroethane, and you can't remember what the 1 and the 2 mean, or the dichloro, or anything like that. So don't saw your branches off. We're going to put knowledge on those branches. So keep them. Now beware the storytellers around PChem. What is a PChem storyteller? Yeah. Exactly. What are the stories you've heard? Reports take a lot, and there's some truth to that for sure. Mm-hmm. Other stories? Harder than OChem, yeah. Here's the reason why I think it's harder than OChem. This is the first time you've had to have, how many prerequisites did you need for this course? My goodness. You had to be through OChem. You had to finish physics 1 and 2. You had to finish calculus 1 and 2. That's crazy. Yeah. And so the reason that is because we do merge that math with organic, and you know, we have to have some knowledge of physics. So when I talk about the harmonic oscillator, I don't have to go back and explain what that is completely. I'll always review a little bit, but you've got to remember that a pendulum or a mass on a spring oscillates, and that's the vibrational motion of molecules. So that's why you need some background in physics. The thing that's less talked about in this class, it's not a prerequisite, but this is an art class, because you have to draw your molecules. And you have to draw them in a good way so that it helps your brain see the three-dimensional shape of the molecule. So we do a lot with shapes of molecules, and that can be hard for someone who doesn't quite think in terms of solid objects that they can rotate around in space. Okay, it is something that you can, I guess that's another thing, you can learn it. You got to let yourself learn it. Eventually you'll have this weird thought. You'll say, oh, is it that easy? You know, you think you're getting it, you're working a problem, you're like, wait, is that the answer? Because that seems pretty easy. It can't be that easy. Yes, it can. Once you start understanding it, that little flip, the switch will flip, and you're like, oh, it's that easy? Yes, it's that easy. Once you get it. That comes from working with people. But yeah, the PChem storytellers. Now, why is it a tendency to tell the people behind you how hard the road was? Because you've already been through it. And so there's just a human tendency. If I get through PChem and I'm looking back at the people behind me, I'm like, man, it was the hardest thing in the world. Because that makes me feel good and look good. So that's why I say beware of the storytellers, because they're going to always exaggerate on the hard side, because it makes them feel good, makes them look good, and makes you nervous. And then for some sadistic reason, people like to do that. Okay. The other thing too is, this is a lie. I will call it out. I had one year or two when the rumor was said, you're just going to fail it once. So just go ahead and take it and fail it and take it again. That was the total lie, told by a person that had taken it 3 times. Okay. So that's not true. You can get through this course if you do what I ask you to do. Okay. So here we are. I want you to know where you are and where you will move to. So there's 2 different kinds of folks, those who can and those who can't. Okay? But they're not static. And then there's those other kinds of folks who will and who won't. Okay? So you make the grid here. This is the person who can do the work and will do the work. Okay? And they're going to be successful in the course. Because what does that mean? I will schedule time in my, regular daily life to study and to prepare and to write my reports and so on. And here's a person who wants to but can't. Okay, they're deficient in their math, or they're just not getting the three-dimensional shape of the molecules. They really are trying and so on, but they can't do the work. And then this person can do the work but makes poor decisions. Okay, and then this person can't and won't try. And what I'm trying to do is to move these people up into the I will category. So I will try. I will put my schedule together and schedule out study time, and I will, not go out on Thursday night if I'm not ready for Friday, and so on, those kinds of things, making those tough decisions. And then I'll move that person from can't to can. So this is my goal, is to get everybody up into that top left corner by helping you manage your time and helping you manage the material. Okay, study the syllabus. Don't print it, in my opinion, don't print it, because it's 11 pages. The university made me do it. They put the simple syllabus on Blackboard, and it's beautiful. It's formatted great, you know, and it just goes on for 11 pages. It's pretty much the same material that I had in 8-point type, all crammed on. So your first homework assignment is due this Saturday night. It's already on Blackboard as a PDF. Pull it down, compare it to the class notes, fill out the multiple choice and so on, and then go on and enter your answers by Saturday night. You don't have to work on the weekends, but I just leave it there on Saturday. So some people are busy during the week and need that Saturday time to study, and so they'll study on Saturday, and then they'll submit by Saturday night. Do not procrastinate. It's due at 11:59. Do not log on at 11:48 and think you're going to get everything answered, because if there's a computer glitch, that's too bad. I mean, this is a machine. It's just going to operate, okay? And so give yourself some time in case the computer acts up. And so turn it in way early. You get a couple of attempts, but only 2, so don't waste them. Don't cheat yourself either by having a friend who's really smart, and you're like, what'd you get on all these? And you enter and you say, I'll study later, and you won't study later. And then you'll get to the exam, you'll have 100 on the homework, and you'll be making 40s. And I'll know that you didn't do the homework. Right? So you're cheating yourself. Okay, there are homework quizzes on Blackboard. Work to understand the terms and answer the multiple choice problems. How do you study for the exam, though? I take the exams pretty much from these homeworks to honor your work on your time, right? You spend all your time on the homeworks. I want to make the exams reflect that. But a good way to study is look at all the wrong answers and compare it to the questions, like, how would he reword this question so that C was the right answer? Because A, B, C, D, and E and all that, those are your vocabulary words. And you need to know about them. And so use that. Don't just study the right answers and say, oh, if I see these words, the A is the answer, because that's a dumb way to study. Look at the text, look at the words, understand the definitions, and work it forwards, backwards. How would he ask this if this was the answer? Is a great way to study. Do the numerical problems and enter your answers in the text box. And I put a 5% flex on there so that if you round differently than me, you'll still get the right answer. Okay? We should be within 5% of each other easily. Now, the scientific notation is a little strange. Instead of trying to write times 10 to the or whatever, we just use an E here. So this would be Avogadro's number. That's how you would enter it into the text box on Blackboard. Does that make sense? You just type it in 6.022 E plus 23, and that's your answer, and it'll understand that that's scientific notation. Excel uses the same thing. So if you're in Excel and you want to type in this, you can type in that same thing, and it will know you're using scientific notation. There are some other study tools that have been built by students in the past. Here's one. There's a Quizlet vocab study tool. If you use Quizlet, it's pretty handy. There's 50 terms related to this course, and so you can pull up, the Quizlet flashcards. You can compete against your friends and so on. And then Kahoot study quizzes. We'll do some of these in class. So it's good to bring something that's internet capable to class when we do a Kahoot. You can use your phone or tablet or something like that. It's pretty fun. I've got a Kahoot for just about every lecture. So if you go in and type in chem_prof and 4448 in the search, you'll find all of them. And then here's where you can find me. You can snap a picture of that. Well, it's in your notes. I also have a science blog that kind of talks about all of the research that I've done and different papers and gives my opinion on certain scientific topics here at pchemforall.com. Is this the 9 thoughts? No, it's the 8. Yeah. Okay, let's go through the Blackboard site. You probably want to set up notifications on your phone, so if something new is posted or whatever, you'll get a notification. I don't know how that's done on your end, so, but anyway, you may want to do that. I've got this blue banner here indicates the lecture section. This is the first semester I'm really using the lab sections, and we'll talk about that in a second. But when you see that, you know you're on in the right class. We have the syllabus up here at the top. The advantage of having the syllabus done electronically through Blackboard is that you can search. You can do Control F and search through the whole document and find those kinds of things. Like if you're going to be late or missed exam or whatever, you can quickly find that information. Okay. This PDF is a schedule of everything in the whole course. Every lecture, every exam, every homework, every lab. And so you'll want to take that and put that into your calendar. Now, a lot of students that I see, I mean, a lot of people still use like a scheduler or a weekly planner on paper, okay? And those are great, but they don't interrupt you. So I would encourage you to start using Outlook. So take all of these items that are on the schedule and go on to Outlook. If you're at the university site, well, it's a pain to get. If you go to the Sam Houston State page on quick links, you'll see email. If you click that, on the email option, which is Outlook, you'll have a calendar. And so you can utilize that. And you can download the Outlook app for your phone, your tablet, and so on. The advantage of that is when you're sucked into Instagram, you're scrolling along, and you've scheduled your study time into your calendar, it'll go boop and give you a notification. It'll interrupt you. Your paper calendar won't interrupt you. So you're gonna get off track and get distracted. So that's a great way to manage distractions. I have to do it. This is a distracting world. And so I have to schedule my research time, schedule my time for all the different tasks that I need. And Outlook keeps me on track. And also that's a skill that you want to build for the workplace in the future. Because as soon as you get into the workplace, everybody's calendar is on Outlook or some sort of calendar type app. You can use Google Calendars. It doesn't matter to me. But the university's paid for Outlook. And then all the course materials are down here in the weekly folders. So every week has its own folder. So we're at 15 weeks in the semester. And so then you go through, and if you look there, you'll only see the week 1 folder. On Wednesday, the week 2 folder will pop up. And then on the next Wednesday, the week 3 folder will pop up. So they pop up on Wednesdays so that you can look ahead to the next week, print off the lab lectures and so on. So within the week 1 folder, this is what you see. You see some lecture note handouts. That's an item up there at the top that has, if you click it, it expands, and then you have all of the PDFs that are partially filled out that you can print for class. It has the homework quiz problems and the homework submission links. So this is everything you need for the homework. There's a PDF you can print out, you can study in your composition notebook, and then you can go here to enter your answers. There's going to be a lab section too. This is the lab piece that has all the handouts for the labs, as it says here. But there's something new this year. All of your lab reports and stuff will be entered into your lab section on Blackboard. So everybody is in Monday, Wednesday, or Thursday labs, and so you should see your lab section in there, like section 11 or 12 or 13. And so you click on that, and that's where you see the submissions. There's no information in those sections. All the information is in the lecture, but that's where you submit your reports and your Excel file. So here's the lab section. So Monday is green, Wednesday is orange, and Thursday is red. So this is what you will see when you click on those. It'll expand, and you'll see these banners, and so then you'll know. I also do that so that you know, okay, I'm in the lab section, not in the lecture. The lecture is blue. So when you're in a lecture section, the top banner is blue. When you're in your lab section, it's one of these 3 colors. Your TA, Kennedy Willoughby, is TA for Monday and Wednesday. Sonia Ortiz is TA for Thursday. And all your lab work will be submitted to your lab section. That'll help. We did it differently for all the previous years, and it was a lot of headaches. So this year I went ahead and bit the bullet and moved all of those little submission links. It took me about a week to do. but it was a week well spent. Okay, so lecture handouts. When you click on lecture materials and handouts, um, you'll see these PDFs that you can print off. Now you've paid your computer fees, your computer use fees, for all that paper they have in the computer lab. Okay, so yes, you could go to Walmart and buy your own paper, but you've already bought paper. And the paper's over in the computer lab. So you go there, plan ahead, and print off your PDFs. I would say print them front and back, flip on the long edge, and then you can punch 3 holes in them using a 3-hole punch. Maybe run to Walmart and get one of those, and then make a notebook. Or if you have a tablet, just put them on your tablet and you can annotate them that way. But I've left some blanks so that you can go through and follow along and keep engaged with the course. It's a great way to keep your brain going because you see that blank and your curiosity is up and we're talking and then you fill those blanks out. Now, if I'm cruising through the lecture and you didn't get the blank, raise your hand. Say, I'm sorry, I didn't get that, and it helps break up the speed of the lecture and so on. It keeps you engaged. These are the 3 sections, 3 computer labs and all of their times. There's plenty of time. I mean, 7:30 to 12 a.m. So all day basically at the Newton Gresham Library, room 200. You go right in the library, take a right, and there's a huge computer lab. So you can print those out in the computer lab. I've also written a book on how I teach PChem. So it's spectroscopy theory in 1 dimension. So you can go there and read the 2 chapters for this first week and a half or so you know what we're talking about. And it's just I think it's, obviously I wrote it, right? So it's great. But it'll explain how we're going about learning spectroscopy. I would suggest getting a composition book because I think it works better than the spirals, but it's up to you to do your homework in. So when you print off that PDF, do the problems in the composition book. You can tab the pages, you can do all kinds of things so that when it's exam time, you've got a single resource that you can go through and you can study from. So I think that's a great way to go through the homeworks. Then you have a nice notebook of all your problems and so on. So just, they're really cheap. Go get one and make it your problems notebook and work all your problems. Okay. And if you want to use it for your lab notebook too, that'd be great. So just take it to lab, just put everything PChem in there. If you fill it up, get a second one halfway through the course, but you probably won't fill it up. If you do, I'll give you $1. If you take that many notes, I'll give you $10. You fill up that composition book. I'm going to look at it, but impress me and I'll give you $10. Okay, where do you go when you need help with the material? Well, I've done my best to give you really good lecture notes, and I've recorded the videos for class, and I put those up on YouTube and so on. There's previous years of YouTube. There's previous years on Blackboard. So that's the first place you go, is to review the material and so on. Then go to the book. The book is deep and in great detail on each of these topics. If you start with the book and start trying to read, you're going to get lost right away. It's really a reference book. So how do you use a reference book? Well, right here, this little picture, that looks like a volume and amount of gas. So we're talking about something with the ideal gas law, right? So I would look in the index of that book for all the entries related to the gas laws or something. And then I would go to those pages and read, find the figures and so on, and read those sections of the book. So that way you're not starting at page 1 trying to read through a PChem text. It's more like a dictionary than a book, a reference material. So when you have trouble with your homework, take some of those same vocabulary words that you're having trouble with, go to the book, go to the index, find that section, and read the details about those vocabulary words. Form a study group. Okay. Sometimes your car stops when you're studying and you're like, is this a wall that I've hit or a speed bump? Your friends can help you determine whether it's a wall or a speed bump because you can't tell. Your car stopped. You're not learning what happened. Okay. And then I'm 4th on the list. It's not because I don't want to deal with students, but I'm juggling a whole lot of things. So sometimes it's hard to find me. I'm in a committee meeting, I'm working with my graduate course, doing research, so on. So you all have the same course, you all are motivated to learn the material. Please, please, please find study partners in your cohort. Lab is a great place to find those folks. It's a smaller group of people, so not this week, not next week, but the third week, you'll all meet in lab and start, getting to know each other and so on. Ask questions in class. That's not on here, but that should be really part of one, is ask questions in class. I guarantee you your question's not dumb, and someone else in class has that same question. And it breaks up my pace, and it makes class way better. Before we get into the rest of the syllabus, are there any questions so far, since I'm talking about questions? Okay. Let's look at how grades will be computed. These are the categories for your grades. Exams are 60%, lab is 20%. Lab is a lot of work, and so you might be pissed. It's like, man, only 20%? I worked that hard on the lab. But a lot of that lab learning goes into the exams. So there's problems on the exam that come straight from the lab, and so it's all mixed together. But in terms of your reports and your writing and so on, that's been graded and put it at 20% weight. I give homework a pretty big weight of 15% to again give you some acknowledgement of taking your own time to do the work. And then attendance is only 5%, but that's enough of a carrot to get people to come and sign the roster and be pretty faithful with that. So this is how the attendance average is calculated. You get 3 free absences from the university. They say if a student misses up to 3 lectures without missing any other kinds of assignments and so on during that lecture, like an exam, they can't be penalized. Okay. So I take the max number of lectures, which is, I think it's like 36, and then there's 42 class periods, but we have exams in there. Okay, so taking out the exams and holidays and stuff like that, we end up with 36 classes where I'll check the roster. All right, subtract 3 from that and we're down to 33. Okay, and so if you are here for 33 days, if I see 33 signatures on those rosters, you've got 100% attendance. Okay, again, you have 36 opportunities to get those 33 signatures. Here's the homework. So maybe it's possible that I ask an impossible question on the homework. Okay, and everybody misses it. Well, no one then is penalized because it's the max number of homework points is in the denominator. So your number of points on the homework is just divided by the maximum number of points. And so if I asked an impossible question, nobody got those points. Okay, so that's your ratio. Your homework average is the number of points you have divided by the maximum number of homework points that everybody or anybody got. And then the same with the lab points. Maybe there's an assignment on there that just no one ever got a perfect score. You could say that. So it's a way of curving the grades a little bit. Okay. So your points divided by the max number of lab points. And then the exams, there's 4 exams plus the final. They're all equally weighted. And so this is your exam average. And then this is how we use those weighting factors. I take my attendance average times 0.05, my homework times 0.15, lab times 0.2, and exam times 0.6. Add that up, and this is the weighted average, and that's what's going to be listed in Blackboard as your weighted average, and then the grades will be assigned on there. Roughly, 90, 80, 70, 60 for the A, B, C, D, F cutoffs. So for your success to bring to the exams, you can bring any dedicated calculator you want. What I mean by dedicated is it's got to be a calculator, not like an internet device. So you can't bring your phone and use your phone as a calculator on the exam. And you can bring a 3x5-inch note card of equations. So it needs to be handwritten. I don't want anybody, again, to like produce one that's really tiny and so on, and then just photocopy that for other people. Because the beauty of having a note card is in the making of it, where you have to decide, okay, what am I going to take into battle with me, right? I've got to have this equation and that equation, and you're writing it out and you're constructing it the way. That's a learning exercise in itself. So that's why I do it, for the learning that it takes to build your own note card. So you don't like mass produce them. So I'll look around the first few times to make sure they're handwritten. And then we'll have a multiple choice section that helps me get the grades back to you quickly. So the vocabulary and things like that, I'll be able to grade very quickly, and there may be one or two written problems where you can show me your thinking. It's not guaranteed that you'll have a written problem. Sometimes I'm really, really busy and I'll just make the whole thing multiple choice. Okay. And sometimes, it just varies. You just never know. Attendance policy. Now, this is something that is only worth a small amount, 5%. But boy, the students sometimes get so wrapped up in this. They're like, oh my gosh, like they're more focused on that 5% than on studying for the exam, which is 60%. So if you miss 4 lectures at the end of the course, you'll have 32 signatures, okay, instead of 33. Oh my goodness. All right. So you've got a 97, not 100. Okay. But you're still saying, dang, that's 3 points that I'm leaving on the table, And that was what I consider would be typically an excused absence. Well, there's no excused or unexcused. I just count the number of signatures. So let's see what the impact on your weighted average would be if you had the 97 instead of a 100 on attendance. Okay. When you multiply that 0.97 by 0.05, you get 0.0485. Okay. And so that fourth absence took off not even 1%, it took off 0.152%. Okay. It's insignificant. So if you're missing 4 classes, it's not huge. I don't want doctor's notes and all of this paperwork to worry about 0.15. Typically I'll curve the grades more than that, so it's not going to hurt you. And if you do have like something serious happen, a car wreck, hospital for a whole week, and you miss a whole bunch, I'm going to know about that, and we can work something out. I'm just trying to head off the 2 or 3 students that are OCD about this, and they're like, I want my 0.15%. Here's 50 different pages of notes from my doctor and everything, and I'm like, no, I don't want any of all that. This shouldn't take either your time or mine. Just come to class and sign the roster. Okay, homework quizzes. Do them in your notebook. So you print the PDF, do it in the notebook, turn your answers in on Saturday night. There's a lot of fear about this policy here. If any part of a lab is not turned in, then you fail the whole course. Okay? So this is in the syllabus. It's an important piece here. And this freaks people out. It's there because a few students in the past would just not do the last lab. So we get close to the end of the semester, they're happy with their grade, so they just quit doing the work in the lab. And I thought, you can't do that when you get out of college, and your boss gives you a task and you're like, I don't think that's a huge part of my job, so I'm just not going to do it. And so I can't let the students sort of get in that habit of being totally utilitarian. Like, if it's only going to work towards count off 0.2% of my grade, and this is 1 out of 10 labs, and I deem it not really important in terms of the number of points, I'm just not going to do it. That if you have that attitude in the workplace, you could get fired. And I don't want to sort of promote habits like that could get you into trouble in the future. Okay, so that's why this policy exists. You have to do every lab. You have to turn something in. Now, if you get behind on lab 4 and you just never are able to get back to it because it's like a train and we're moving through the whole semester, you got to turn something in. Okay, even if it's dramatically incomplete, still you turn it in. Okay, and communicate. It's really, when I say unaddressed absences and unaddressed things like that, that means you missed lab, you didn't talk to your TA, you never talked to me the whole rest of the semester. That's the severe case where you would fail the course. Okay. So it's not me trying to figure out a way to fail you, it's just to head off those bad habits. Communication is the real issue. Now, I never liked the discontinuous. I'm going to describe this. Nature hates discontinuities, and so do I. Okay, you're working on your lab report, and it's due at 11:59, and you turn it in at 12:01, and you lose like half credit or something ridiculous like that when it was only 2 minutes late. Doesn't everybody hate that? Yeah. Okay. So I let you turn your labs in late, but it's on an exponential decay. It's not discontinuous. Okay. So here's the equation. If you are past the due date, okay, by a certain number of hours, which is t here, divided by 24 hours, so it has a half-life. 24 hours late, you've got half the points maximum. 48 hours late, you're down a half again, so it's a quarter of the points. And then, 3 days later, so it's really only just worth 1 point. It doesn't drop down to 0, it drops down to 1. That way I know you turned something in. If the TA puts a 0 into the grade book, that means you didn't turn anything in. If you turned in something, your name on a page, you get 1 point. Prevents you from failing the course. Okay. But this way, you're looking at it, you're like, I've got one more paragraph to write. I'm going to turn it in 30 minutes late, write the paragraph. Okay. And the TA will look and it was like, it's less than 1 hour late. It's not even worth taking off. Okay. So you stayed up till 12:30 instead of 11:30. Okay. But don't procrastinate. But that way there's not this step function where it's 5 minutes late and you lose a ton of points. I wish everybody did that, but they don't know how to use exponential functions. So, but we do because we're chemists. All right, so don't plagiarize. 10 consecutive words taken from a source without citation or quotation is plagiarism, and Turnitin will find that. It'll be bad. So don't do that. If you're going to use AI, I'm not going to say you can't use it, but it's so obvious. This course, when you're writing about the material, you need to use specific language and you need to be concise. And AI is the opposite of that. It speaks pretty generally and it's very verbose. So it stands out dramatically when you put AI in your report. So what you need to do is you need to blend it in. You can use AI for brainstorming. And if you do, down in your citations, say, whatever, Chat GPT and whatever, edition was used for brainstorming the paragraphs in the theory section or something like that. Use it as a cited source, or Grok 4 or whatever AI that you like to use. But you got to blend it in, okay? When I say blend it in, you got to delete all the flowery stuff that AI is putting in there, and then you can just keep the meat. And what that requires you to know what is the meat and what is the fluff. So then it becomes a teaching tool. So it's okay to brainstorm with AI. How could I say this better? And then edit it and blend it into the report. Make it sound like you, not like AI. Okay. Now, if you just put in a bunch of AI and I see it, I may say, okay, let's get on a Zoom and I want you to tell me what this word degeneracy means. You wrote it, or did you? Right? So I'm gonna quiz you on the technical terms that you put in your report, and if you don't have any clue what those terms mean, then you get a 0 on that report. So if you're going to use AI and it's going to give you words, you better know what those words mean and be able to describe them. Okay, so again, it becomes a study tool. I'm not saying you can't use it, but if it's using terms you don't understand and you turn those in as if you do, I might ask you about them. Okay. Plan ahead on the exams. If you printed this off or have this PDF, it has a typo in it. It says December 7th, so I changed it to December 11th here. That's when our final is December 11th. It's correct on Blackboard. It was just on the PDF that I uploaded for this morning's lecture. It's incorrect. Okay. If you are going to miss an exam, say your car is not starting or you missed your alarm or whatever, call my phone number immediately. Leave a message so I know you're not just, blowing it off or whatever. You're trying to figure out a way. Many times students have said, I've overslept my alarm. And I say, can you take it right when you get here? And they're like, yes. And so I'll leave it with Mrs. Haynes or Miss LeClaire, and they'll give you the exam when you get here. Maybe I'm in class or something. But we'll work it out as long as you're proactive. Okay. Don't wait 2 days and go, oh yeah, I forgot about that. Can I take it now? Okay, so get ready for the rest of this week. What does that mean? We don't have lab in person, but we do have a lab this week. It's the Excel Bootcamp. So there's a playlist in the lab section on Blackboard. You can go to YouTube, watch those videos, build your own spreadsheet, and then you turn that spreadsheet in for this week's lab. It's due, like if it's a Monday lab, so today's lab, next week is Labor Day, so the following week, Sunday night before the next lab Monday is when it's due. That's 2 weeks to do the boot camp. Don't wait that long. Just get it done this week before things really heat up. And there's a lot of Excel in this course, but honestly, that's one of your most transferable skills that you get out of this course. We have students constantly write me back and say, man, Excel has been great. Read chapters 1 and 2 of the book and read through the PowerPoints, print them out, or put them on your tablet and read through them before the next class. Okay. So we got 2 minutes now. Don't wait to ask your question after everybody's gone. Ask it publicly now. Okay. Because I've got another class. Yeah. Lab's just reports and Excels, yes. So no exams for the lab. Yes. You work it out with your TAs. Yeah, say, tell them ahead of time if you can. Um, so that way they can work with you. Yes. Yes. That's a good question. They're there the whole time during the lab, but then you may, like, if you can't finish in the 4 hours, maybe you can schedule a time with them. But that would be something to ask them if there's enough time for their availability. Okay. Hold on, folks. We got 1 more minute. Let's make sure everybody gets their questions. Yes. Yes, both sides is good. And save them. Don't turn them in with your exam because you get to use all of them on the final. So that's nice too. Mhm. Relying on the note cards. Yeah. I mean, I say that once in a while. I'll just put one in just so I make sure that you use the one I'm thinking you should use. Mhm. About leaving lab early, please don't do that because we pay the TA to be here the whole time, and they're there for you. So stay the whole time and try to work with each other. If you really are done with the lab, I mean, start studying for the course. You've carved that out of your schedule, so take advantage of that time. There are laptops in a cart over there. They're a little on the slow side, so if you do have a personal laptop you can bring, that'd be great. Um, the only issue with when we do Gaussian calculations is we don't have a Mac version of the Gaussian software. We only have PC versions. There is a PC version available on Blackboard that you can download and install on your Windows laptop. Um, the only caveat to that is you technically should delete it at when you graduate, okay? Because it's a site license for students while you're here. All right, one more. Labs occasionally will go upstairs or in the lab, and the TAs will tell you when you need to have closed-toed shoes and pants and so on. We'll do some of the spectroscopy measurements in my lab. So for those days, you'll need to bring sweatpants or some kind of shoes to cover up. Okay. All right. Y'all have a great time. Thank you for your attention.